Hey, so these are the latest version of my little LED dimmer boards. Um, I think I'm on about version 3 at the moment. The first one, they've all worked, but they've been quite noisy. So with this one, I've removed quite a lot of the ground plane and kept the traces to just thick enough for the amount of current that's going to be going through. And yeah, first test, I'm going to make up a couple and use them to drive about 10 meters of LED strip. Well, about 8 meters of LED strip. This cob stuff, which is 8 watts a meter. But I'm gonna set it so it's maybe pulling about 3 watts a meter, something like that, 2 or 3 watts a meter. So here we go. I've still got a couple of the components to get out. It's the microcontrollers, these little 10p jobbies, WCH 10p jobbies, which I can. Oh, bejesus. They're lively, they're jumping around. Right, okay. Get up ahead of pressure. Right, capacitor. Fuse. Another capacitor. 3.3 volt regulator with a bit of ground around it just as a heat thing. Little 100 nanofarad capacitor. Oops. I think I've gone a little bit overboard there. 100k pull down resistor for the gate, 100 ohm series resistor to limit the current through the microcontroller pin, 100 ohm. I think it works out that there's still about 30 milliamps coming out of the pin, and it does manage to switch at the speed that I want to switch, but it's probably a little bit too much for the chip, I would have thought. Okay, and the MOSFET. Wodge loads of the paste on there. And a little bit there. Right, too much there. Good job it's very forgiving, really, because I'm quite slapdash. So let's place the components on this first one. So 10U capacitor. That's the input to the 3.3 volt voltage regulator. 1U, that's the output. Oops. And then a 1 amp polyfuse. It's probably the most expensive single component on the board, actually, that. Or maybe after the microcontroller. It's all very cheap stuff, this. I think these were 5p. Oh, no. These voltage regulators, because I've had to use the ones that take in a higher voltage, because 16.8 volts blows up the cheap AMS 11171, so I needed to get the more expensive ones. So actually that's probably the most expensive component, followed by the microcontroller, followed by the polyfuse. The rest are all, I mean, pennies and half pennies. So regulator, 100 nanofarad capacitor, microcontroller with pin 1 being there. Get on there. 100k resistor. I couldn't find my 100k resistor, so I'm using an 83k, 82k. I'm sure it'll work. I actually tested those out, and they tested at 80, so we're fine. And then the 100 ohm resistor. get bedded down. And the MOSFET. I'm not actually using, it says there KND 8103. I've got quite a few of those, but I'm just trying a slightly different spec one. Still pretty cheap, slightly less cheap though. So the idea is to just make this really as quiet as possible. It's switching at 20 kilohertz as well, which should be sort of above most people's audio hearing range, but for some reason I was getting like real whine. Every time you turned it on, it was real whine. So I've redesigned. This is the new design. We'll see.